Thank you everyone for coming. My name is Chris Mack. I'm with Basis Technology. Basis provides software components for text analytics applications, including search. We're best known for the language analyzers we provide in search, so better recall in about 35 languages. But I'm here today to talk about fuzzy name matching. So when you've got names that you want to match that aren't represented the same way, how do you go about doing that, and how we did it specifically in Solr. Now, name matching is prevalent in many areas, but I think one of the most compelling cases and powerful cases that you can think about is security. And we all remember what happened in 2013, the Boston bombing. I was there. My wife, who was pregnant at the time, we were there. Fortunately, not right at the finish line, but close enough that it was a real wake-up call. Just about life in general, right? This is a scary world to live in sometimes. But the congressional investigation that happened after this showed that we could have stopped the Sayonara brothers when they were coming into the country. We knew about them. They were on a watch list. But they weren't caught. They weren't stopped at the border, and they weren't being watched probably as closely as they should have been, because the name that had been provided to us by the Russian government was different enough. The name and the date of birth were different enough, what was on the watch list, to what the documents were when they were traveling. So name matching in security is a common case. We also see it in fraud and in the prevention of fraud. So banks, mortgage companies, Airbnb, right? Has to worry about fraud. Has to worry about the types of people that are opening their homes to other people. Uber. All these companies have to worry about fraud and the identity of people. And then in commerce, we have many applications as well. Matching in databases, doing database linking. If you've got people names that are represented differently in your CRM, product names in commerce that get represented or typed in as queries differently. All of these are variation and ambiguity problems that are special to names of people, places, locations. So before I dive in any further, though, I want to get a sense of the folks in the crowd. So who here are Solr developers, actively developing Solr applications? All right, that's what I was hoping. Pretty technical crowd. That's typical for Lucene Revolution, which is awesome. So we'll be talking today not just on the use case, but also a little bit about how we went about implementing this. So right on for that. So who has dealt with some of these name challenges specifically in their applications where you've got people names that you need to match? All right, good. Well, you came to the right session. That's good. So, and then the other question is, how about across multiple languages? How many people have sites with multiple languages? Okay, good. Those are all areas that we address at Basis, and we'll talk about. But to level set for everyone, and for some of those that might be newer to name matching, I want to just touch on what makes it a hard problem. And there's two central problems in name matching. One is the variety of names and the different ways names can be represented, Sayonara, for example. And the other is an ambiguity problem, that even if you've matched down to the right name, are we talking about the right person, right organization, right product, as it were? So I've got a really simple name, Chris Mack. It's a real straightforward name, but it's amazing the number of different ways it can be represented. My first name, Christopher, with a K, with a C, with an F. I mean, there's so many different ways you can spell Christopher. The last name can't get much simpler, but invariably I get MAC as a way that my name is represented. And those are just a couple of examples of variation. Variation is actually broader than that. These are some more examples. You have phonetic misspellings. You've got married names, hyphenations, token orders where the order of the different names come differently, nicknames, and then cross-language names as well. Names, and that's another aspect of the Sayonara problem, in that it was a Cyrillic name that had been transliterated into Latin characters. And there's many ways to represent a name and the sounds of a name when you do that. And so it presents its own set of challenges. The other problem is name variety. So if you do a search for Christopher Mack on LinkedIn, you'll get 323 entries. I had never had any idea there were that many. I would have never even guessed there were that many of us out there running around. But those 323, these are just the top couple examples. And And even though the name is spelled identically, we've solved the variation problem, we still have that ambiguity problem to deal with. So how do you go about solving these variety and ambiguity problems? Anyone in the crowd that has gone and tried to do this, what were some of the approaches that you used? Mm-hmm. Mm-hmm. Yeah, yeah. So, so even just on matching on the names, what do you do there for the variety of names? Do you do anything specific to try to match them? Regular expressions. Yep. Common approach.
Basically, I did one little thing for the NIH where they had a problem where they wanted to track authors of papers of people they were funding, how often they were publishing. And the little thing that I came up with was just trying to figure out how much confidence you had when you had first name, middle name, last name versus just first initial, last name. You have less confidence. You know, C Mack.
Right.
It might be you, but it might be Charles Mack or something.
Right.
So it was different confidence levels depending on how much you could match on the initials versus the name.
Right. Right. So that's one of the phenomena, the idea of, we call them token deletion. So we think of the series of names and a name as tokens, and one's missing, it's a deletion. If there's another one that we don't see, it's an addition. And then the initials, similarly, will count that as a token, and if it matches the first letter. Those are all things that can contribute to a score, which is the other thing you brought up there. Because even if you start matching these things, where you start getting into some real challenges is, how do you represent that in a score? Especially when there are so many different phenomena. So we'll get to that as well. So if you start doing some searching, there is quite a bit out there in terms of best practices. How do you address fuzzy name searching? This is a Stack Overflow article. I think sums it up pretty well. The best practice recommended today is that you take the name that you want to search on, you create one field for each phenomenon you want to deal with, and you store that name again and again and again in those different fields. And those field types are storing the name in different ways. So you might have a field that deals with phonetic matches, one that deals with non-Latin characters using like an ASCII folding filter, and that list can go on. The more of those phenomena you want to cover, the more of those fields you need. And that does two things. One is it makes your queries really complicated. Doable, but messy. But it also drives your recall up. Because every one of those fields has the opportunity to match partially, you end up with a lot of noise in your queries. So, so the idea, and this isn't terribly new, but it's create a single field. And anyone could do this, right? You take one field, create a custom field type, and below that create individual subfields to deal with each of those phenomena. And then you could do a couple things, right? Once you do that, well, now you could have one document that has a couple different names in it. You could have maybe the primary name and an AKA, and then your queries become a little simpler. So that's a step in the right direction, but it still has a number of challenges around it. What if the name you're matching on has multiple phenomenon in it? How do you combine those into a score? Now this is a real example. Jesus Alfonso Lopez Diaz. He is on the OFAC list. OFAC is a list, one of the many watch lists out there. It's published by the Treasury Department. You can search on it. It's online. You can download the list. About 10,000 individuals, I think, in it. And this is an example of how that name might have multiple phenomenon that combine to make it a very difficult match. So Lopez Diaz, those are two different misspellings. Chewy is actually a nickname in Latin America for Jesus. So this is actually these names aren't that far off when you look at it through the lens of the various types of variation that are out there. So how do we combine that? So at Basis we said, can we do better? We already had our name matching technology that we do. We handle all those phenomenon. We've got a lot of the common approaches that you'll read about out there, plus a little bit of our own special sauce. And then one of the unique differentiators, we also do searching cross-language. We have a lot of language experience in our business, so names that are represented in different languages we can search across those. So we said if we combine that with Solr's re-rank function, we thought we could make a pretty compelling plugin to be used with our product. So that's what we did. And it's very simple to configure. So if it's simply adding a new field type and new fields to your Solr config. And once you've added this type, you can add single fields, single name fields, like the primary field in the AKA example that I mentioned earlier, and get that right into your configuration. Once you've done that, what's happening behind the scenes is when you go and you index a document, let's say Robert Smith with the date of birth, right, two fields. Under the hood, we're actually taking Robert Smith and we're creating, there's a whole set of subfields that are hidden to you. The idea is to keep it simple on the surface. But we store all these what we call high recall keys in those fields to have the highest match possible for various names that we might match against this name in the future. Yeah.
So basically, you said that I left Robert Smith and I created actually 10 subfields, which how do you create those subfields unless it, because for example, we do Germany, like the company, your English is different from the company in Germany. In that case, you create like, let's say we have the company name, you create like 5 subfields, such document for the name.
So the question is, what are we doing in those subfields and around different languages as well? Each different phenomenon has its own subfield. So what we do in each field varies based on that phenomenon. So for example, phonetic matching, and this is pretty well known. It was linked to in that Solr article. Phonetic matching there's a number of algorithms out there, double metaphone, SoundX, and it creates common sound expressions that we store. And there can be more than one of those for a given name. And so for that phenomenon, for that name, you'll get entries for that. But it varies by which phenomenon we're talking about.
I was just curious how generally you would identify all the different variants. Like, so Robert, you could call him Bob, Bobby.
Yep.
And
Yep.
it's like you'd have to have a dictionary for every possible name out there. And every Robert has their preferred nickname.
Right. So nicknames and cognates, right? So cognates are similar to nicknames, that they're other forms of the same name. And these are synonyms, essentially. And that's the way you can tackle it. Internally within our product, it ships with lists, and lists that can be expanded. So yeah, essentially, for the nickname phenomenon, we just see that as just another phenomenon, just another type of variation of the name that we have to deal with. Chewy and Jesus, in my example a moment ago, that's in a nickname list. Yeah, our product ships with a dictionary, and it's a common approach. If you look at at those best practices, using a synonym, we don't use the synonym function directly. We use this technique that I'm describing here, but it's a very similar approach. Yeah.
And with this technique, when you enter in the user docs, do you make sure, like, is there some sort of reverse where if someone puts in the username Bob Smith, do you translate that to Robert Smith?
Yes, I think the short answer is yes. The question was, what do we do on the query side? And I'm going to get to the query side in a second. So on the index side, we create these high recall keys. And then at query time, there's 2 steps that happen. And you can always think about it as a 2-pass search, like a blocking search and then a fine-grained search. On the first pass, what we do is on that query, we perform a similar process. So like query expansion, right? We take that name and we break it up into tokens, and we look at things like nicknames and whatnot, and then we query against all those high recall keys, and we get back a lot of results, right? It's a high recall pass intentionally, and then what we do is we use Solr's re-rank function to look at each of those that are returned from the index against our search term, and we rescore them. We use our own scoring methodology. We return something, a score different than your Lucene score. This is a similarity score. How similar is the search name from the potential document that we got back? And using all those variations is how we do that. So visually, the way you can think about this, that first step at index time, we're creating those high recall keys, we're storing those in Solr. And then at query time, we do a similar process where we expand that into many possibilities. We do that combination, we get back a large number of results from Solr, and then we do this re-rank query where each one of them gets a score. And I'll talk a minute about what you can do with that score. One aspect of that two-pass is that it gives you fine-grained control over accuracy and speed. The more names you pull back, and the more of those you want to look at in that second pass, the more resources you need to throw at this to keep it going fast. So you have both a control over what match score. We have match scores, so you could draw a line and say anything over 70% match score, which is a decent score, commonly what our customers use, to say that's something I'd really want to consider as a possible match, and everything else ignore. Or by a number of docs, you say, hey, always look at the top 100. And that will vary based on how many names you have in your index, how important recall is. You can't miss someone. In security applications, you can't miss someone. You have to throw more hardware at it, look at more names, because the cost is just too high. But in commerce applications, you might make a little bit more of a different trade-off there. So in summary, how it works, did I skip a slide? No, sorry. So in summary, the way it works is we've got that custom field type, and it does that split, and then we've got the custom re-rank function that rescores the documents, and it gives you that configurability around that trade-off of performance and whatnot. So I'd like to open up to questions. So the question was, on the first phase, do you get back all the documents that match any of the phenomenons? Yes. Yes, you would get back a Lucene ranked order of possible matches for any of those phenomena. Yeah. In the second phase, that's where we provide a specific rank and similarity. On the first phase, you're getting back a Lucene rank, and as you know, Lucene ranks are relative, right? They're relative to the entire document, relative to the other documents that are returned in the search. In our second pass, it actually generates a score, and I thought I had a slide in here. That's why I must have accidentally deleted it. So this is a good question. I'll spend a second on it. In the second pass, when you take these high recall keys and you're looking at each document at your candidate name, we generate the score. Now, what do you do with that score? You've got a couple different options. These are configurable. So let's say you've got a name that is a very good match, 97%. We think there's a very, it's not an exact match, but we think it's a very high match. And you've got that score in your query result. You have the option to replace the Lucene score. Let's say if all you're doing in this query is name matching, just replace the score. You can actually take that, the re-rank function would take that score, and that would make the new score in your result list. That would make that the top item on the list. Or if you're doing, if you've got other fields in the search, let's say you've got date of birth, right, as another field, or gender, or some other fields that you're searching on, and you're combining that, you can decide what your weights are for, and what weight do you want the hour score that we call it, RNI is the Rosette Name Indexer, so we call it the RNI score. What weight do you want that to have on the overall document score? So you might, if the name match is really important versus some of the other criteria you have are a little less important, and that might even vary, based on what that particular query is, the source of that information, and so you do that all at query time. You can decide what that weight, what those weights are.
Why is the RNI score better than just Lucene?
Well, they're fundamentally different. I'm sorry, I'll repeat the question for the microphone here. Why is the Lucene score, why is the RNI score better than or why is the RNI score better than the Lucene score? And they're just fundamentally different in terms of what they provide. The RNI score is a similarity score between names. So between the names being searched and the names in your index. And if all you're doing is a name search, that might be the exact number you're looking for. But if you are if you're trying to do an entity-centric search, you're trying to find a person and you have other information about them, you may just want that to be one aspect of your overall document score. I got two questions. First in the front here. Yeah, no, you. Yep.
Actually, my question is related to the top bullet, structured text. So when you said entity disambiguation, so if you have other context information that's a part of the full text stuff, and the example I use is, we all know that Jimmy Page is a rock star. This morning knows Jimmy Page congressman. And the paragraph was about Jimmy Page as a rock star. Well, if you find also Robert Plant and Led Zeppelin in there, we know, okay, that's the rock star guy. If it says, congressional district or something, we know about this other guy, then, oh, that's that guy, right? And that stuff would be in the unstructured text, I think, rather than in the metadata. But does your, I forget what you call it,
Right.
that and the last sort of
Right. So really good question. So I'm going to I'll try to summarize so everyone can hear. So what do you do with unstructured content, names in unstructured content that are ambiguous, right? We talked about two problems at the top of the presentation about the variety problem and the ambiguity problem. And how, if all you have is unstructured content, how do you deal with that ambiguity? So the examples I've been using so far are what I'd refer to as structured content. You've got the person's name, a date of birth, a gender, a nationality, and those are all things that you can combine in your query directly and provide field weights to and use for disambiguation. The challenge with unstructured text, there's a handful of challenges with unstructured text. So you've got a paragraph of text. First, what if there are people names in that text? So the first thing you might want to do is extract those people names, right? So this is assuming, depending on where you're starting with the question, you have to find the people name first. So you might use an entity extractor. That's another product that we sell at Base, is our entity extractor. So you need to find the people names that are in the text, and then you can match them against a list, but you're still stuck with that ambiguity problem. The 323 Chris Macks in LinkedIn. How do you know one from the next? And there might be hints in that paragraph of text that would help you do that. There's two ingredients to make it work. One is you need to be able to extract those hints. Your example, is it Ed? Ted, sorry, Ted. Ted, your example was Jimmy Page, the rock star, the congressman. And they're going to be talked about in very different lights in all likelihood, right? It's a congressman, we're talking about legislation, whatnot. And if you had a knowledge base, the other key, a knowledge base that has biographical information or common information about that individual, you can do matching between the two. And this product I'm talking about here today, RNI, actually doesn't do that. This does the variation piece, and you can disambiguate in Solr with different fields. We actually have another product called our name resolver that's designed to do knowledge-based resolution. So you've got this name in unstructured text, you've got a bunch of context around them, but how do you match that against a knowledge base? And it's things like how that person's mentioned, if they're mentioned in, or the things that are talked about around them in context, and then what information you have about that person in the knowledge base. So the variation is based on phenomenon type, and what I'll actually do is I'll just pull up that variation slide so I can speak to a couple of different types here. So for each of these phenomenon, that subfield exists and it's algorithm driven. So for the nickname list, and this question came up earlier, what do you do for nicknames? Well, that's a list, right? So if Bob is a name in my query, I look at my list and I say, okay, there's all these different variations for Bob, and I include those in my high recall query. But some of these other phenomena, like the phonetic matching, that's all algorithm driven. So for that match, we call an algorithm, we get a normalized version of what the name sounds like, and we store that, and we do the same thing on the query side. And other examples, like dealing with names, languages, right? Languages, each language has different structure and characteristics around it. So that's per language, there's an algorithm that drives that, and how those keys are created and stored. So, yeah. So I mean, there are a lot of dictionaries out there. So if you do some searches, you can find nickname lists pretty easily. There's a lot out there. You can also harvest names. So I know people have used Wikipedia now to go and look for names, or maybe a combination of those techniques. Yep. So organization names. The question is, what do you do for organization names? IBM versus International Business Machines. Initials and abbreviations are handled in person names here in this example. We've got initials. Where's my initials in here? J.E. Smith, James Earl Smith. So General Electric, GE, IBM, GM for General Motors. If you didn't have those names in a nickname list, which you can extend our nickname list, you would still get some score, but there's very little information to go on with just G and M. There's only 2 letters. You'd get a score, it would show some similarity, but if you were specializing in corporate names, there's only, I think it's 10,000 listed companies or something like that. It's such a small list, and it's pretty easy to gather all those variations. If you're focused on company names, I'd recommend creating creating synonym lists or what we call overrides to deal with that within our product. Great questions. Keep going.
I just want to clarify on the second stage that
Yep.
you talked about the re-ranking the R&I function. Is that something that's available in Solr out of the box, or is that a proprietary component that you guys use?
So the re-rank is available in Solr. That's a feature of Solr. What we did was we created a method that re-rank calls that actually creates the score. So it's a combination of both. Sorry, and the question was, is re-rank a feature that we built? And it's not, but we call a method in the re-ranker that we did build.
And specifically the similarity, right? Re-ranking results based on similarity of what you matched on.
That's the part we do, and it's part of the central challenge, because you can go after these phenomenon individually, but when you have multiple phenomenon and then you want to create a common score for all the phenomenon, that's where it gets a little hairy. And that's really what we added in on top of our tool set for Solr. I'll go over here first.
What happens if my extraction engine fails and I see a name that's like name semicolon forward by another name?
So what happens if if you send in names that aren't particularly well formed, and it's garbage in, garbage out with most systems, right? We do deal with some. We expect some noise in names. We expect concatenations, hyphens, commas, extra spaces. These are things that we see a lot just because of dirty data in the world, so we expect those. But if you really send in like a string of text that isn't, the name's in there somewhere, or half a name or 2 names, your results are going to vary. So tuning. So the question is, there must be a lot of tuning, and there is. In fact, I mentioned, two of these very coarse grain accuracy versus performance levers that we have. Each one of these phenomenon actually has a set of fine-grained tuning capability. And we'll even go in and adjust those on a per client basis some of the time. And there are some ML models behind the scenes per language actually that we also use. So those can be retrained with customer data. So there is a lot more going behind the scene, but we intentionally hide it because the defaults work for a lot of people in a lot of cases, especially if you're doing the security case or the fraud case where you've got a watch list and you're matching people names. You just turn it on out of the box. You get pretty good performance.
So I'm wondering, when you pull up like too many results. So for example, if someone's simply searching for John Smith or Jay Smith, and you have all this the results that are stored relevant to that search, how do you rank who gets on top? Do you have any system for that? They're all similar.
Yeah. So the question is, how do we deal with even names that are very similar, and how do we re-rank those? So the scoring is very fine-grained. So if you had a lot of similar names and they're all very similar to your query, they're going to come back ranked. They might be clustered very tightly. You might have a whole bunch in the 90s, 96, 97, 97. I mean, it's a real number. So I mean, it's 0.9, 0.972210. I mean, you'll get a rank back. They'll have an order, and it does its best. It's
But you're saying it's up to the user to then filter out which one he actually needs to try to find, or I mean, what if the user doesn't provide additional information as to what he's trying to do, or do you implement a predictive thing about the user?
Well, I mean, we can only further filter on the information we have, right? If you want to know their favorite color and that's not in the data, that's a tough task to do. So, but if you search on a person, you get a bunch of similar results. If you have more information, I was using even something as simple as gender, you can cut your results in half. What year they're born, what nationality they are, when they last appeared in your system. You could introduce all those things into how you go about ranking it. But unless there's something else to go on, either provided by the user or that you can guess for the user, then there's not a lot to do. Sure. Yeah.
So wondering, how about family? So for example, this page is a star, and this page is a policeman or whatever. Yeah. But at least there is human being.
Yeah.
So what about, for example, if somebody names a flag?
Mm-hmm.
So the flag is a American flag, flag is a name.
Right. So Mack truck, and Chris Mack, right? That's a challenge that's actually a little bit upstream. When you're first identifying what your names are in unstructured content, that's when this problem, we usually come into this problem of ambiguity of entity type. Are we referring to Apple the company or Apple the fruit? Mack the person, Mack the brand of vehicle. And if you don't know this already because you're dealing with some structured content, right? If you're dealing with structured content, you've been given the names of lists, you're going to trust that that's a name of list, and if you got dirty data, you got dirty data. But if you're dealing with unstructured content and you're extracting that information, then it comes down to the quality of the extractor you're using to solve that ambiguity problem. So in each language, in English, for example, the way that sentences are written, you can fairly reliably extract a person mention from a product mention. That you can do that fairly consistently. Yeah, Ted?
Yeah, my favorite example of that is entity extractor plus Lincoln Junior High School was the first.
Yep, I could see that. Depending on how junior high school is in a sentence, I could see that definitely being confused. So the way that we approach, there are common approaches to entity extraction, right? One is dictionary based, right? And if junior is part of a name, that might signal that you're dealing with a name string. So dictionary-based, rules-based type of extractors will get tripped up on that. The other approach is statistical models. So based on the structure of the sentence, how likely is it that this is a person name? So we use a combination of patterns, rules, and lists when we do entity extraction to try to get down to the right entity type before we try to match against a name list. We got about 2 minutes left, so yep, go ahead.
In this case, like this, Lincoln Junior High School, basically you can tell if you have Lincoln Junior, you're human, but if you have high school, you're not human. So basically you have two lists. Which one you study that yes, which you know and study no.
So I think you're providing a potential solution to solve the ambiguity problem. It comes down, if you know what type, whether it's Mack truck or Mack the person, if you know that, then yeah, storing in separate fields is great. The ambiguity comes into play when you don't know. And if you've got the original unstructured text, using entity extraction, you might be able to find out. All right, do we have one last question over here? So do we pay attention to capitalization? It counts. It definitely counts, but we don't rely on it because you can't rely on it. Your question earlier about names that match really well, but how might how might the scores vary even if you have really good matches? That's a good case, right? Where maybe one's capitalized and the other isn't. Well, you're going to get a little bit better match on the one that's capitalized because yes, it definitely does factor. Every one of those phenomenon factor in. So again, thank you everyone for coming. My name is Chris Mack. Basis has a booth or a table or whatever we have out there. So if you've got more questions about name matching or about any other unstructured problem or improving recall and search in multiple languages, stop by. Happy to talk to you about it. And hope this was helpful and fun. Have a great day.